Okay, so what you have here is you have line AB going this way and line CD going that way. And then you have this line, let's see, what is that? That's FE, line FE, right? That crosses. And the thing is that it crosses both line AB and crosses line FD in the plane. So, all three of these are coplanar. They're in the same flat two-dimensional surface. And so then this line FE crosses both of the other lines. So this is something special that we call a transversal. Okay, it's a transversal. That's what that's called. Okay, and I'm gonna just make that big if I can. Maybe it won't work. I don't know. All right. So anyway, this is called a transversal. It's a situation whenever you have two lines in the plane that so they're called coplanar, and you have a line that crosses both of those lines. Now you have what's called a transversal. And at a transversal, you have all kinds of angles that are formed. So the ones we're going to focus on right now are called alternate interior angles. Alternate interior angles are these angles that are on the inside of the transversal, so between the two lines that are both being crossed, but on opposite sides of the transversal line, of this line that crosses across them. So these are the angles such as angle FED, which you can see I've marked here, and it's measured at 124.43 degrees. And maybe I'll use my pencil real quick, and I'll call this angle right here. This angle will be angle 1. Okay. And then maybe I better move that measurement inside just a little bit. So there's angle 1, and then the other alternate to angle 1, alternate interior, is this one over here, which maybe I'll call angle. Well, I'll just call it angle 2 for now. Okay, but it is angle AFE or angle EFA, vertex at F, and then rays, FA and FE. Those are the rays that make up angle 2. So these are called alternate interior angles. And I always think of it like, if this was a canal bank and this was kind of a bridge going over the canal bridge or going over the canal bank, well then these interior angles are the ones inside the canal, right? Whereas if we went outside the canal, those would be exterior angles, but interior angles are inside the canal, right? And yet they're on opposite sides of the bridge. That's why we call them alternate interiors. So let's get that written down here, and I'm going to make this large here and see if I can do this. So we're going to call this alternate interior angles. Okay, so now what you're going to notice about these alternate interior angles is, guess what? The measure, as you can see here, the measure of angle 1 and angle 2 is the same. Now, maybe that's just coincidence. What happens if I change, the setup here? Now, this one measured 154. They're still the same. And these two are still the same. So you might think, oh, they're always going to be still the same. Well, sure, looks like it. Looks like they're always still the same. Well, they are always still the same, but only there's a condition under which they are going to be still the same. So they are congruent, and that means that they have the same measure, right? But only when the lines are parallel. The lines being crossed must be parallel. Okay, congruent only when the lines being crossed are parallel. So that is a condition that has to be met. And let's go ahead and mark these. You'll see these little arrows. If I put an arrow on the line, and they both have the same number of arrows, that means that they are parallel. They're moving in the same direction. So these will only be congruent when the lines are parallel. So you can see that, whenever I move these around. Oh boy, didn't mean to do that. Let's try moving these around with my move tool, that they always are the same measure. Doesn't matter. But of course, that is dependent upon them being parallel, right? As long as they're parallel lines. If this line, let's put another line in there and see that it doesn't work if the lines are not parallel. So line GH and line AB are not parallel. I clearly made them not parallel. And if I were to, check out the alternate interior angles of those two, so here we'll call this angle 2 and this angle here HIE, which I better measure here, it is not going to be the same. HIE measures 146.56, right? And this one's 134. And it can get really goofy. If I make this an acute one here, you can see that they just don't stay the same. Okay? And that's because this property of alternate interior angles being congruent only applies if the lines where the transversal is crossing happen to be parallel. In this case, they do happen to be parallel. Okay? So we'll go ahead and let's get rid of that line. And we may as well get rid of these points. So we're only going to deal with parallel lines. So now what you have to do is you have to come up with a proof that says angle 1 and angle 2 are always, these alternate interior angles are always going to measure exactly the same. And so to do that, we're going to talk about what a postulate is. So let me put a postulate. Let me put the term postulate down here. Let me get my text tool again. And we're going to put down here, a postulate is something all mathematicians agree to accept without proof. Okay? And basically it's something that appears to be true, and so they say, hey, let us agree on this postulate, something that appears to always be true. Okay? So in this case, the postulate that they're going to agree upon has to do with these two angles. And I get my pen back out. Let's take a look at them. This is angle 1 here, and we'll call this one angle 3. So angle 1 and 3, okay, go back in here. Angle 1 and 3, 1 and 3 are called same side interiors, or sometimes they're called consecutive interiors. So consecutive kind of means next to each other. Same side is another way of saying the same thing. If you think about it, they are on the same side of this bridge, of this transversal that crosses, right? They're on the same side. So that's one way. If you read some math textbooks or go to some math classrooms, they'll call them same side interiors. Other textbooks will call them consecutive interiors. But in any event, it refers to the same thing. They're on the inside and they're next to each other. And so there is a postulate, and it's sometimes called, I'm going to make this a little bit smaller, here we go, and it's sometimes called the, oh boy, let's do this, here we go, it is sometimes called the same side interior postulate. Let me make that nice, here we go, interior postulate, and what it basically says is that same side interior angles are supplementary. Okay? It says that the same side interior angles are supplementary. That's what that basically says there. Okay? Oh boy, I'm zooming back out here for a second. There we go. Hopefully that's a little bit better. So now if I know this postulate, I can use it as a proof, as part of a proof. Okay, we accept that these two are supplementary. So what does that mean? Well, because of the same side interior postulate, it means that angle 1 and angle 3 are going to be equal to, the measures are going to sum to 180 degrees. That is the definition of a, supplementary angles, that their sums measured to 180 degrees. So now, how can we prove that 1 and 2 are equal to each other? Well, this is going to be similar to what we did with vertical angles, okay? I'm going to go here with a little bit smaller text, and we're just going to type out our logic. Here we go. The first thing is that we know that 1 and 2 are alternate interiors, right? They're called alternate interiors angles, right? They're alternate interior angles. Why do we call them that? Well, that's by definition. That's what we call definition. They're on the opposite side of a transversal, and in the interior of the transversal. So we call them alternate interior angles. So we start there, okay? Now the next thing that we know. The next thing that we know is that 1 and 3 are same side interiors, and that's also by definition. Okay? Just by the definition of what we call same side interiors, they are, these two are same side interiors. Okay? The next thing that we know, because 1 and 3 are same side interiors, we know that 1 and 3 are supplementary by the same side interior postulate, right? So that means the postulate tells us that, hey, we can accept, and we don't have to prove it, we can accept that 1 and 3 equal 180. And so now we can just do 1 plus 3 equals 180, meaning the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees, and this is by the definition of supplementary angles, right? Okay, and let's just post that there. So that's our next little piece of logic here, right? That these two are supplementary by the postulate, same side interior postulate, and then also that means that they are they sum to 180 by the definition of supplementary angles. So now we're going to talk about, let's say, angles 2 and 3. What do we know about angles 2 and 3? So 2 and 3 are a linear pair, right? And that is by the definition of linear, I'll just put a linear pair, okay? So because of the definition, they have a common vertex and their non-adjacent sides are opposite rays, so they are a linear pair. So what does that tell us actually? Well, that means 2 and 3 are supplementary by the linear pair postulate, right? And then what we have is we have that 2 plus 3 equals 180, and that is by the definition of supplementary angles, right? So there we have, we're saying that these guys are a linear pair, which by the linear pair postulates, another postulate tells us any two linear pair are equal to 180, or that they are supplementary, and then the definition of supplementary angles means that they add up to 180. Okay, we're almost there. We know, let's kind of wrap up a little bit here what we know. We know that 1 plus 3 equals 180, and that's also equal to 2 plus 3, right? And so that is what we've proved so far, and so we can say that 1 plus 3 equals 2 plus 3 by the transitive property of equality. Transitive property is the one that says, hey, if two things are equal to each other, then or two things are equal to the same thing, then you can cross over here and say they're equal to each other. This is equal to 180, this is equal to 180, so now they're equal to each other. That's a transitive property. So the transitive property of equality is what we call that, okay? And then that means we can take 1 plus 3 and subtract 3, and that will be equal to 2 plus 3 subtract 3 by the subtraction property of equality. So all we're saying there is that you can subtract the same amount, 3, from each side, and then if we simplify that, we start with 1, and we add 3, then take it away, and start with 2 and add 3 and take it away. We're going to simplify, and we'll know that 1 equals 2, and that's all we did was we simplified, so by simplification. Okay, so there is our whole proof, really, that we need. We know that these two equal 180 by the same side interior angles. These two equal 180 by the linear pair postulate. So they're equal. Their sums are equal to each other, and if we take 3 out of the equation, then 1 and 2 must be equal to each other, and that is the proof of alternate interior angles.